EC2 key pairs and security groups. Well, my friend, we are well on the way to getting our instance up and running and really understanding all the pieces around it. And I felt as I wanted to start this thing, I go, we got to just get our bearings, because even as I say that, we're well on our way to get our own instance running. I'm sure many of you have already gone out there and gone next, finish, and you're like, well, there it is. It's not that hard. I've got a running instance. Absolutely, you can have a running instance in a few minutes if you just next finish it. But really kind of putting together all the pieces. So I want to make sure we don't get lost as to where we are in the concepts. I'm going to bring over the EC2 management console. And I'm in the instances area. I've got right here just a little Linux instance I've got set up this morning just to play around. But I wanted to bring up the instances. Let me just click on Launch Instance just to get our bearings. Now, we went through, we talked about what it looks like to go through the wizard, going through the AMIs. What is an AMI? The frozen in time hard drive. Where do you get the AMIs? Creating your own AMIs. The community, the marketplace, all of those kind of things. We went through and figured out how to get an instance going. So I'm just going to grab, let's grab Windows 2008 R2. We talked about, how many instances, the types of instances, the processor size, the memory, how you scale that. Not even shown here the I/O that's included within each one of these instance sizes and why that's impactful. We talked about the availability zones, the regions, and what that is. We looked at the pricing, all of the different pricing that we could do for on-demand versus reserved versus spot. Whew. Even as I do this, I'm like, man, we've talked about a lot, but it's so easy to just, next. Okay, I've got it. It's good. But now you really understand all these pieces. So let's see where we go from here. Okay, we're into the advanced instance options. I'm going to put those to the end, right? Just because it'll just make more sense if we talk about those at the very end. I'll say this is a great one, prevent against accidental termination, to where you have to come in and uncheck this box before you can terminate an instance, because it's all too easy to blow one away accidentally. So continuing from there, let's pick up here. Okay, so that was my bearing check, right? We know where our instance is. We know what kind it is. We know, EBS storage. We know all of that kind of stuff. So now we're into the tags. What are tags? Tags are just a way for you to identify your instance however you want. It is kind of a free form. I mean, think of it as a micro database that you can use for each instance to describe it. So when you're looking for certain instances, you know what they are. And I would suggest it's all too easy to just say, well, let's add my own tags and just make them up. But I would suggest sitting down with your IT group, unless you are a one-man show or one-woman show, then sit down and say, hey guys, let's agree on what tags we're going to use to describe each one of these. Let's come up with some common syntax, because if you look, these keys, these tags, the key values can only be 127 characters, and the values can only be 255. So it's not like we're having a big paragraph here on everything that this instance does. So for instance, this is I'm creating a Windows 2008 R2 instance. Let's say the name of this is SD Core TS01. I'm actually using a naming convention that I use for my own data center. SD Core to me says, name of my company that I work with, Core. Core is the data center. TS stands for the function. I use, for instance, TS is terminal server, or I might do a DC for domain controller, or FS for a file server. I've got my own key. And then 01, this is the first terminal server that I have at the data center. So if you never had a naming convention, bam, there it is in 2 seconds or less, the naming convention for you. So that will be a name that can now appear. You can see it kind of behind the scenes here. It's this little name. I didn't put any tags in this one, so it says empty. That's not very descriptive. But I don't have to just stop at the name. I can go in and say, well, let's add a description. Description will be, and again, 255 characters, you don't have much. Let's just say RDS gateway to reach internal apps. I'll just say internal servers. How's that? And you can keep adding another tag and another tag. As many tags as you want. And let's just say creation date. It is, what's the day? 5/25/12. And go on. And you can see up to 10 individual tags that you can use. Now, I'm going to show you this in a minute. Well, Yeah, well, I'll show it to you in a minute. I'm going to click on continue, save those tags because I want to now get into the key pair. So let me pause there and flip over to the concept. What most people do when they get to the key pairs on their EC2 instance is they kind of, well, actually, let me show you. They usually come into here and they go, okay, and by default there is no pair. This is just a pair that I created previously for my Linux instance. They come in here and it says create a new key pair or proceed without, and people go, let's not do that. And then it says, oh no, you can't connect to this instance unless you do that. You go, oh, okay, then let's do this. Okay, I'll type it in, and they create and download, but they're just kind of going through, not really understanding the power of what they're doing and the power of what this really is. This goes back to public and private key cryptography, and I always, I could give you okay, type this and then go here and do that. You can Google that and find it, but to really understand the why behind it, that's satisfying. That's to where I get it. Okay, so understanding public and private key cryptography is huge because it's really how almost all the secure communication in the world works. This all goes back to decades ago when there was an instructor, a college professor, and his student named Whitfield Diffie. That was the student, and I believe it was Martin Hellman. It was the Martin. I think it was Martin. Hellman was the college professor, and so these guys were. And this is decades ago. They were sitting there trying to figure out how do you have secure encrypted communication across a public network. Think about it. You're right here, right? Sitting at your computer, and something almost all of us do nowadays is do online banking, where we can go and transfer account balances, make payments, online bill pay, so I don't have to mail it in the mail and all that. So it's very convenient. But in the middle of all of this communication is the public internet with evil people that are trying to steal your bank account balance and trying to steal the ability to transfer information. So I need to have some kind of secure encrypted session between these guys. I have to have something that secures it so these evil people in the middle of the cloud can't find it and see it and be able to get to my bank account balance and all that. And they're going, okay, well, think of this. College professor, students sitting there looking at each other. Okay, how do you do that? Back then, encryption keys were very common to where you would have a key. And a key, I'm visualizing it here as a key, but it's a mathematical formula, right? That really scrambles the data. So let's say I want to transfer $150 from my checking to my savings account or something like that. Before I send it, it runs it through this encryption key, which just is a big mathematical algorithm. It goes blah, 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 and scrambles it all up to where you can't understand it. Well, the person who has that key can also reverse that to figure it out. That's so to do encrypted communication. I would have the online bank have the key and I have the key, and then we just kind of encrypt it between. It's like, well, that's simple, but how do you get the key? oh yeah, forgot about that. How do you get the key? How do you get the same key that the bank has so that you can encrypt it without the guy in the middle getting it too? You can't just have the bank send you the key. Do you see this dilemma? So Martin and Whitfield were sitting there. They're like, how do we do this? How do we do this? And the way the story is told, and this is, you can go look this up in Wikipedia if you want. I don't know if it's there. Maybe it's there. The student, Whitfield Diffie, was at home asleep at 2 or 3 in the morning. Wakes up in a cold sweat and goes, "I got it. I know it. I've got He dreamed the algorithm for what we now know as the Diffie-Hellman public key encryption algorithm, to where you now have, instead of one key, 2 keys to start your communication. A public key and a private key. So I'm going to show you how it works across the internet, and then I'm going to apply that same mindset. It's actually much simpler when you look at it from an EC2 perspective, but understanding kind of the big picture. This is impress your friends conversation. Seriously, they're going to be like, wow, really? So here's how it works. When my computer connects to the online bank, let me flip colors here. Connects to the online bank. It says, okay, this is going to be identified as a secure channel. The way that works is the bank, their web server, says, I'm going to send you a security certificate. Ah, certificate. Some of you may have seen that before, like when you're surfing the web and it comes up and says, "Hey, this certificate is not valid. Do you want to proceed?" And everybody's like, "Ah, don't show this to me again." And hit yes. Well, it's not good to have an invalid certificate because everybody should have a valid certificate saying this is who I am. And the certificate says, this is my identity. I am, the Bank of Arizona. I have this level of encryption. This is the date and time I got this certificate. And I've got, you might go, what's that little squid on there? It's the stamp. There's actually something called a certificate authority out on the internet. You can, like VeriSign is a big one. Many different certificate authorities that before this bank goes into business online, they go to the security authority and says, here's all our information about our business. Not all of it, but the requested information. So you know that we really are the bank. Because it would be horrible if somebody, pretended to be the Bank of Arizona. Matter of fact, that's called a phishing attack. When you get those emails where it's somebody pretending to be eBay or Amazon or something like that, it's a phishing email. It's somebody trying to pull the wool over your eyes to get you to type in values over there so they can compromise your data. So we need to have these certificate authorities on the internet that says, okay, this is really the real one. That's why it's so scary if somebody sees that message that says, this is an invalid certificate. Do you want to proceed? And people are, yeah, because a lot of times people don't pay the money to have a certificate really validate their identity. So you're playing the game like, I really hope this is the real Amazon, the real eBay, the real Bank of Arizona. So if you have a certificate authority give one to you, then it's validated. The browsers won't pop up that security warning and that kind of thing. But also on here, and here's the key, no pun intended, the key of what I'm trying to say, is the bank's public key. That's why it has that name. A public key is available to anybody. And it is, you can think of it as a full encryption decryption algorithm. It can encrypt, it can decrypt data. However, it is only a one-way encryption. Start putting these pieces together here. If I encrypt something with that public key, that key cannot decrypt it. It must be decrypted with the private key, which is the reverse of the formula. Talk about that in a second. So let me finish this story here. You connect to the bank, they send you their certificate, which includes this is who I am, I'm valid, I'm not a fake, and here's a public key, a mathematical algorithm that we can use, or I should say that you, little computer, can use for encryption. Now notice I said encryption, not really decryption. But this computer, your browser, Internet Explorer, Firefox, Chrome, whatever browser you're using, built into it has a certain level of encryption. And based on where you are in the world, there's some governments that say, well, we want to be able to see what you're doing. So they may block the ability to use really high encryption versions of this. They have very low encryption values and things like that they allow. So based on the browser that you're using, let's just say you use 128-bit encryption. Let's just say I'm using Chrome. Chrome will then generate what's called your session key, which is just a key. It's an encryption decryption. It's the old school, the original one key to rule them all. It is an encryption decryption algorithm that you and the bank will use for your session. Okay, whoa, wait a sec, Jeremy. This got weird. I thought you said the public key did encryption. I did. But we don't want to use that for all of our communication because then I've only got half of a formula. I can encrypt stuff, but I can't decrypt stuff with it. So what my browser does is generate a one key to rule them all encryption session, encryption key, and encrypts the encryption key. Really? Yeah. So it takes the public key from that certificate and encrypts this encryption key, which it then sends back to the bank. The bank gets it and says, okay, I'm now going to use my private key, which it never, ever, ever sends to anyone. That thing is, hidden away. It's the bank's. It never sends that private key to anyone because if it did, oh my goodness, it would compromise the whole security because whoever got that evil person in the middle, if they got the private key, then they could decrypt all these session keys from the users coming back in. So you never send the private key. So the bank gets that encrypted session key back, decrypts it, and now I gotta use a new color for this. This is so cool. And now both sides have a session key that they can use for their communication. And that's what they actually use for all of the communication between those two for that session. That's why they call it session key. As soon as you close your browser, it's done. Session key is deleted. The next time you connect, you get a public key. You regenerate a brand new session key for the session. Wow, isn't that cool? That's how it works. That's how all the communication works on the internet. Now, I said... I shouldn't say all the communication. All the secure communication works on the internet. Now, I said the EC2 side of things isn't that bad because we don't really need a session key. They use the idea of public and private key cryptography in such a way that we can use it to retrieve our passwords or to log into a system. So let me explain. I'm going to hop back to the instance I was just creating right here. So we got to the point we went through and defined all the tags. Great. Let's continue, please. There we go. And it says, do you want to choose from your existing key pairs or proceed with or create a new one? Now, normally if this is the first instance you create, this will not be here. So I'm going to create a new one as if I hadn't done that before. So let's just call this CBT pair 2. It's just a simple identifier name. Might name it after your organization or whatever the case may be. But that pair is being assigned to this virtual machine. So I'm going to click Create and download the key pair. And what it's doing, it kind of happened down here below. You can see it downloaded cbtpair2.pem. I'm going to go, and now we're into the security groups, the firewall, which we'll see in just a second. But I'm going to show in folder. Let me... Wow, there's all my downloads. If you want to see what I've been downloading lately, you can check that out. But right there is the CBT pair 2. Now, if I right-click on that and open it, edit it with Notepad. Where's Notepad? Let's try that again. Okay. Oh, there we go. It was just taking its time. All right, so right here is the RSA private key. This, if you ever wonder, well, what is that mathematical formula? That's it. Well, that's actually the key for the mathematical formula right there. That is the private key. So you have just been given, with what you now know about how web security works, that's a big deal. Amazon just gave you the private key for your system. Save it. You need it. They maintain the public key. So let me finish going through. I'll do the security groups in just a second. I just go through and launch this machine. So it's going to just go through and start building that machine over there. There we go. So it's loading up. I can already see my name right there. But I want to right click on this guy. Hang on. What was I thinking for a second? Oh, there we go. I totally lost my train of thought for a second. I was thinking about what was in my download folder. So we've got the two machines. We have a Linux instance right here. This is Ubuntu Linux. And then right here I have my Windows instance that I just created. It's actually generating. So it's going to take some time, usually about 10-15 minutes before that thing is fully ready and ready to rock. So while we're waiting for that to load, let me jump right here to how the key pairs are used for Windows instances and for Linux instances. What happens in the Windows world is we, as we generate the machine, get the private key. It's sent to us by Amazon. It's downloaded, and that is something you want to hang on to, you want to save. Because once that Windows instance is ready, you need that to get the default administrator password. Meaning, let's flip back here. I have this instance that's currently initializing. If I right-click on here, there's an option that says Get Windows Password. Now it's going to give me an error saying, hey, you can't do it. Wait at least 15 minutes before you try to retrieve the generated password. But once you do, you're going to see it bring up a window. Actually, I'm just going to camp out and wait. I'm going to check my email and then come back. Okay, I'm back. Checking email, bad idea. An hour later, here I am. So I've got the machine sitting right here. It's generated. It's been running, waiting for me. So I now can right-click on it, hit Get Windows Passwords. Now, when we're talking Windows systems, let me get back to my slide here. When I'm talking about Windows instances that are running, the key is definitely critical, but only really critical initially. You need it to get the default administrator password, and then once you get in, then you can change the password to whatever you want. For Linux, this is how the private key is actually how you will authenticate from here on out, unless you start creating different user accounts and things like that within Linux. So I would say, in terms of course, you need it for both of them, but Linux, it's definitely got a more ongoing purpose. So right here is the encrypted version of my Windows password. It's saying, after I put it through the public key, I have this little blob. I believe that I can decrypt that using the private key called CBT pair 2, PEM. Do you have that? Now, there's a couple ways I could go about this. I could either go in there and actually copy and paste this whole private key into this little box and tell it this is my private key, or a little easier is just to go in and let me just find it. CBT pair 2. Open, and you can see it puts the private key right just as if I would have copy and pasted it. And I click decrypt password, and bam, there it is. I now have my decrypted administrator password. Now I can pull up remote desktop connection. Let's go ahead and highlight this name. That is now my name that I can connect to. Paste that in here and connect. Voila, it comes in, says what username? Well, the user, it says, is administrator. And my password, VNDZY, exclamation point 7AVP. Says, hey, well, talk about certificates. Even remote desktop uses a certificate. Look at this. Hey, this is just, what a great way to talk about what I just described on the public. It says, this certificate is not from a trusted certifying authority. That's okay, because if we had to go buy a CA certificate for every remote desktop session we wanted, it would get a little costly. So I'm going to click on yes, accept that certificate, and I am now in. Now, first thing that I'm going to do as an administrator is get into this Windows Server 2008 instance and go to my Windows security and change my password. So I would type in the old password and then the new one, and then I'll say, not that I wouldn't care anymore, but I don't really need that private key anymore. Excuse me, because I already have the password changed at that point. So now let's talk about Linux. Linux has the ability to authenticate users based on solely the private key. A little different than what we just did with Windows. With Windows, we went in and used that private key to figure out the password and then logged in with username and password. With Linux, you can get in without a username and password at all. It just the private key can get you into Linux. Now, actually using the private key with Linux is a little bit more difficult than with Windows, because Windows, you don't really use it, at least not for Windows itself. You just kind of use it to figure out the admin password, and then you chuck it. You never really use it again after you change the admin password. But on the Linux side, it's part of the authentication. When you get the PEM file, you didn't really get a private key. Well, you did, but it's kind of it's like the meat. It's like, you know, you took off all the packaging. There's the meat of the private key. You know, I'm chew on it right there. But with Linux, you actually have to take that and generate it into a full-blown private key. And to do that, I mean, you can go on Google and find a million step-by-steps to do this. I just grabbed one for OS X if you're using a Macintosh. First thing that you want to do is get your EC2 command line tools. It's a little package of tools, a little compressed file of tools that you can download. Unzip those, and you use this command right here, EC2 add key pair, and then you say PSTAM. I mean, this is just a name. Whatever you want to name the key pair, you put it in there. So they have a great output right here showing. I typed that in. It says, okay, key pair such and such, and that's where right here you paste that private key, the meat I just showed you, into that, which ends the private key, and now that generates a key that you're able to use to get into your Linux instance. So let me scroll down a little bit. This is again using OS X. They go in and just show using some more of the EC2 command line tools to list the images that you have and see what images are in your account from the command line. So we haven't even gotten into the command line tool. We're doing everything through the AWS Management Console right now. We'll get there, but this is just a sneak peek of what's to come. So they do some other things, but by the time it's said and done, this is where the glory happens. It says, I'm now going to SSH into my instance. I'm identifying the key pair of RSA. This is the key pair that we generated way up here. with this PSTAM key pair. So I'm saying use that key pair to access the root account of blah, blah, blah. And that's the actual name that Amazon would give you when you generated your instance to access it. And that's where you can now get in. You're now accessing your virtual machine using SSH from a Linux prompt, and you can get in, and if you want to, you can go into the SSH area and add user accounts, so you don't have to use that key pair every time, and maybe just use that for initial access like we do with Windows. So now let me answer this last question. Okay, what if I lose my key? Well, let's talk through that. If you lose your key, first off, on a Windows side, let's say you generate the instance, you never change the admin password, you forget the admin password, and yeah, I'm coming up with a harebrained scenario here. You always use that PEM key to figure out what the password is and paste it in to access it via RDP. You lose the PEM file, so you can't get your password. Now, first and foremost, Amazon cannot get it for you. They do not keep the private key. They send it to you and they say that is your responsibility. Hang on to that. So if I'll say in both Windows and Linux, if you don't have the admin password, you haven't changed it from the original. And same thing with Linux. If you just lose that PEM file, that's the key to generating your private key to access it. You're locked out of the system. I mean, the short answer is go ahead and terminate your instance. Create a new one. But maybe you're at the point where you've gone in. You've got. Let me bring my AWS Management Console back up here. You've gone in, you've got some actual data in SD Core TS01, and you're like, I can't lose that. I don't just want to terminate the instance. Well, the good news is this: it's either an ephemeral or it's an EBS storage. Most of the time, people run it from EBS. You can see right here the root device. It's running off of EBS. So the hard disk, the contents are still there. What I would suggest is this: right-click on this guy and create an AMI image. And by the way, this is a great time to talk about this. If you haven't created your own AMI, this is how you do it. I can say the image name is, let's just say SD Core TS01 backup. I can't get in there, and you can put a description, no reboot. Select that, hit yes, create, and what it's doing is it's now creating an AMI behind the scenes. Now remember, when we go in and create a new instance, I can click on the instances and choose. Let me see if I can launch a new instance with this going. See if it shows it there. No, it doesn't. Yeah, we've got to wait for it to finish. So it's creating an AMI instance. So you see where I'm going with this? You're going to want to go in there and now generate a new instance from your frozen in time AMI. At that point, you'll be able to use a new private key, generate a new private key, and get into that system. Now, a lot of times when you do this, some services won't be started. You'll have to manually go in there and start the services. Some of your disks may not be mounted. You may get in there and go, oh, I only see the C drive. Did it lose everything? Go into the disk manager in Windows or mount some use some mount points in Linux to mount the disks back in, and all of your data should still be there. It's all. I shouldn't say should. It will still. It doesn't. It's not like Amazon just loses data. It will still be there. You just have to mount it all back up and get into it. So all is not lost if you lose your key, but it does definitely cause a hassle. Well, that's enough fun for now. I want to put a dividing line there so I really have the time to expound on security groups. There's a lot to think about when you're setting them up. So we talked about in this nugget tags, and actually there's something I totally forgot to show you. But I was going through defining the tags, and you're probably like, okay, well that's great to see them, but where do you actually use them? Where can you find them? Well, you remember for this SD Core TS01 virtual machine right here, or instance, I actually defined the tag of, I think, the creation date and things like that. You can go up here to the Show Hide button, and that allows you to add your own tags to this list. Click, let's add them all in there. Click on all of them, and now I can see. If I expand this out, now I'm obviously running a little out of room here, but now I can see all of the custom tags that I've put in there. And I have seen it's sometimes when you put this, it shows all empty until you click the refresh button. So if you do this yourself and you're like nothing shows up, click refresh and it'll show up for you. But that's your nice way of doing it. Now you can filter on them. You can search for them. You can, I mean, they're part of your image list here. So that's a really powerful tool. So we talked about tags and adding those to your instances that are running. We also talked about EC2 key pairs and in all their glory to talk about what the key pairs are. We even talked about public key, private key cryptography, and the mindset behind it, and then how we applied it to Windows instances, to Linux instances. What happens if you forget your key? All those kind of things we went through. So in the next nugget, we will talk about security groups. But for now, I hope this has been informative for you, and I'd like to thank you for viewing.